Okay, so I'm going to do the best I can with this. We're going to talk about the intermediate value theorem. I apologize for this weird video, but I wanted to demo something. So you need your pipe cleaner and your 3 beads. The intermediate value theorem says that we're going to let f be a defined continuous function on a to b, and let s be the number with f of a less than s less than f of b. Then there exists at least one x with f of x equal to s. So what this is really saying, and I apologize for the terrible lighting, is if you take your pipe cleaner, okay, and I want you to go ahead and slide the big bead on. That is the S value. I think our book calls it a C. Actually, first I meant to have you turn this into a function of some kind. So you can bend it into whatever kind of function you want. Okay? And go ahead and slide that bead on there. And then these are your endpoint beads. So these are your A and B beads. So you slide that endpoint bead on there. And we slide our other endpoint bead on here. So now what I want you to do, oops, I lost my endpoint bead. All right, so imagine there's another endpoint bead on here. Okay? Because I lost mine. All right, so what I want you to imagine is that we are on an XY axis, okay? So you could actually think of my nose as the Y axis, all right? So basically what happens is this C value, it said S in the theorem I showed you, but it's C in our book, takes on every Y value in between these two, as long as it's between those two X values. So that's what the intermediate or the InterBEADiate value theorem is. So that I can take, as long as I've got two solid endpoints, I've got a, I can, this bead in here, this value takes on every single Y value in between those two endpoints.